Hello and welcome back to another one of our videos where we show off all the goodies that we make for you guys. And today we have another treat. Today we are going to show off a vacuum and pressure system. And this is an automated test cycle that this system is going to perform. And that is for the MIL standard. I believe it's 810. So it's MIL-STD-810 testing standard. I could be wrong here, but it's one of the MIL standards. I'll have to double check and refer because I can't memorize all of these standards that are out there. But yeah, that it's one of them, and I'll actually comment in the video below which standard it was. So let's get started. And so this system is a fully automated turnkey system. All you got to do when you receive it is you just plug it in the electricity, and then you supply air, right there, pressurized air up to 145 psi, 150, that's max. So any the standard shop air here in the US will work, and then you're ready to go. Of course, turn on the vacuum controller and let's talk about the system. So first, as you can see, this is a full turnkey acrylic vacuum chamber automated vacuum system. And it comes on a table frame structure, lockable swivel caster, so you can move it around your shop, your facility, wherever you want. It is a front loading. The chamber size is 12-inch cube. And let's talk about some of the components. So let's start with the first ones first. So USB feed through. This is a USB 2.0 feed through. You can connect your USB connector here, and then on the inside there is a corresponding USB. They're both females, so you can connect your USB signal or USB cable on here, connect them inside, and you're good to go. Likewise, this is a wire feed through. There's 18 gauge wires, and the same thing. You can connect your wires here. You just strip it, and they're copper wires, and you can run your electricity or electrical signal from the outside towards the inside at full vacuum without compromising vacuum. This is a special potty that we've designed internally, and also a special feed through that is intended only for vacuum applications or pressure applications in this case. And then moving on top we have a safety pressure relief valve that will pop open once the pressure inside this chamber exceeds a certain threshold, and this is for strictly safety reasons. I believe this one is set to 15 psi, so anytime this goes above 15 psi, 1.5, and that's gauge pressure, this valve will pop open and it will release the pressure, always keeping this chamber safe, always keeping it within safe pressure limits. And then we have a digital vacuum gauge which shows in torr and millitorr. And it is also calibrated with a NIST traceable calibration certificate. In the rear, we have two solenoid valves. One is for vacuum, one is for venting. And let me actually come this way and show you something. This is a flow control valve, and that is all connected to the vacuum valve. And the vacuum pump, those two solenoid valves in the rear, and then this digital absolute pressure gauge, they're all connected to the brain of this whole system, which is this vacuum controller. Now you guys have seen these. They're made by us, by Senatron, and these enable you to do quite a few cool things. One is altitude simulation, and other ones is also, you can do manual. You can also do some step profiles that we've added, and we constantly keep improving and adding new features to this guy. So by the time you're watching this video, we probably have another feature, another improvement on this thing. We have about, at this point, almost a decade of work and research and development into this vacuum controller, and we were very proud about this guy. And then let's move on. So that's the vacuum side of it. And then let's move on to this pressure side of it. So this is a manual vent valve that opens and closes. This is just there. Generally, you keep it closed, but there are times where you may need to manually vent this. So this is a good design practice. You always have to have a manual vent valve on any type of a chamber. And then moving on, this is a pressure valve. This is a flow controller for the pressure, and then this is a pressure regulator, okay? And all of that is connected, like I said, to a pressurized line. And what we're gonna do, like I said, this is a MIL standard 810. And in this particular requirement, we will go from sea level, which is 0 or 760 absolute torr absolute pressure, to 50,000 feet. And then we're gonna hold it for a certain time, and then we're gonna bring it back. And then at the same time, likewise, we're gonna do a pressure cycle, because it also needs to go not only from 0 to 50,000 feet, it also needs to go from 0, which is sea level, to negative 1,500 feet, okay? And we do have a conversion table, and we use the NASA US Standard Atmosphere 1976 table that we use to calculate and curve fit the altitude versus absolute pressure. And I think that is it. And we will also provide a link in the comments below, or just below the video, and you guys can click on that link on the PDF file, and you're more welcome to download it, use it, because it is very useful. It is a altitude versus pressure conversion table, and it helps you determine, calculate the altitude or convert altitude to absolute pressure. So let's get started. I'll talk about this vacuum controller, and I will talk about how you can get started on doing a cycle from 0 to 50,000 feet. So main menu, this pops up as soon as you turn on this controller, right there in the back. And then in the main menu, you hit F1, okay? So this is already set up for 50,000, but I'm just gonna go and run through the settings really quick to explain. Okay, so this is the the current chamber vacuum. You notice it's 660 torr. That is to be expected, because we are in Salt Lake City, Utah. We are about 4,300 feet above sea level, and that is why it is showing 661. The set point is in millitorr, which is 88.56 torr. Dwell time, it is the current dwell time once it reaches the target vacuum of the target set point right there. And then that is the set point for the dwell time, which is 30 seconds. Hitting F3 will get you to your set target pressure. And this is where you can increase. These two are decrease, these two are increase. It is currently set for 88.56 torr, which corresponds to a target altitude of 50,000 feet. And then we have the dwell time. I do not know what your dwell time is, but I have set it here for 30 seconds, just for illustration purposes. And then hitting F3 it just keeps kind of going through, so it keeps cycling through. This is indefinite dwell time. That means if you want to hold it at 50,000 feet forever, or as long as this system is running, you can hit on and you can hold it indefinitely. And then we have the ascent rate. It's off right now, so it's not going to calculate ascent. We also have the descent rate. It is also off. It's not going to calculate descent. And then we're going to go back to the main menu. So let's get started. Hitting F1 starts the cycle. And here we go. It's going to go down, and it's going to take us to 50,000 feet. You'll notice that this guy right here, the chamber vac, is changing. You see it's at about 450. It's going on 400 torr. Once it reaches 80 torr, it's going to close. While it's pumping down, let's also talk about this thing. These are the thumb clamps that you need to close the door. And you don't need it for vacuum. You only need just to initiate the O-ring compression for vacuum, because the vacuum will keep pulling the door towards it and compressing the O-ring. But you do need it for pressure, because we're going to do pressure. And they keep this O-ring compressed under pressure, because they pull the door, since the pressure is pushing the door out, okay? These are specialty designed and made by us, Senatron. And likewise, since this is a front-loading chamber, here is the hinge, the door hinge. And that is also specialty made and designed. Oh, it actually closed. So the cycle closed. So it actually got there to about 80, right there. Sorry, it reached 50,000 feet. Now it's holding it. You see 88, 0.357. This one is 88. So it's actually pretty accurate. It's actually pretty cool. Yeah, we've actually improved our accuracy quite a bit. We have an algorithm in there that actually keeps it calculating, keeps it holding it. And yeah, that's kind of cool. So right there, it's venting. You guys can see. So it hit 30 seconds. Now it's venting, and it's going to vent. Okay, so we're fully vented, and I don't think you can hear me talk when it's venting, but what I wanted to say is that once it reached that set point, you guys saw it, and then it was counting down. Once it counted down to 30, it vented the chamber. So, okay, let's move on and let's do a pressurized cycle. Let us simulate negative 1,500 feet, and we can simulate it anywhere in the world by setting it up. So I believe negative 1,500 feet is about 800 torr absolute, and we're gonna do it. And so let me show you how you can do the pressure cycle. So here in the controller, what we're gonna do is we're gonna go into main menu by hitting F5, and then you hit F5 again. You're gonna go into manual mode. And in manual mode, in order to actually create an airtight seal right now, is you have to turn on the vacuum valve, and you also have to turn on the vent valve, okay? So you make sure that both of them are closed, and so you have everything closed here. And then what you got to do, here's your pressure valve, and all you got to do is open it. And right now you're going to see this pressure go up. See that? To about 800 torr right here. 792, 793. This is a high accuracy pressure regulator. And it's been set to about 800, so it's going to get you there. Okay, so right there, right now we're simulating inside. The absolute pressure is about 795 torr absolute pressure, which is corresponding to approximately negative 1,500 feet of altitude. Okay, I think that's it. That's all. And then you do your test cycle, it's going to hold it there forever. There's no timer here. This is a manual feature. And to be done with it, you just close this valve, okay? And here's your manual vent valve. You can vent it here. You don't have to do it. What you can do, you can either push, actually, you can just hit F5 and exit, and it's going to vent both valves, or you can just hit F3 and vent it. Right there. Can vent it right there. That's it. And that is it. That is your system. So I think we have covered it all. So thank you for watching. Thank you for being our customer. Thank you for the likes, the subscribes, and for the comments you guys leave on our videos. And if you guys have a need for an automated turnkey vacuum system, altitude simulation system, leak testing system, we can do it. You guys go on our website at Senatron.com, hit email us or contact us, and we will be happy to take a look at what you got. All right, thank you so much, and you guys have a good one. Bye-bye.